Hello everybody and welcome to a new video. In this video we will connect the weather monitor we made to a local MQTT broker to make the data available to other applications. So get ready and enjoy the show. In this video I will explain the code added to the ESP, set up the local MQTT broker, set up the local NTP server, and finally we will see the result. Let's start with the code. So this is the same code we used last video. I just added these commented chunks of code. So let's uncomment it and explain it. So these are three libraries for the three functionalities we added in this code. First one is for the Wi-Fi connection. This is for the Mosquitto, the MQTT server, and this is for the NTP client. This is for the Wi-Fi setup, MQTT and NTP consecutively. You will need to edit those for your Wi-Fi name and your Wi-Fi password, and this is for the machine running the MQTT server and the NTP server. This is the function to connect to the Wi-Fi. It's pretty simple. This is for the MQTT server. And those two are pretty important because sometimes the machine hosting the MQTT server is turned off, or maybe the Wi-Fi is not available. So I will need to buffer the data collected at the time where the machine was off, and keep it in a buffer until the ESP is reconnected. Then it will flush the buffer. This is to push to the buffer to store the data in the ESP, and this is to take the data from the ESP and push it to the MQTT server. You can edit this for how much data you want in the buffer. Here I set it to 150. You just need to pay attention to how much RAM your ESP has. Okay, for the setup I added the connection to the Wi-Fi. This is it. And for the MQTT server 2 here. And this is for the NTP. This will infinity loop if the NTP server is not set up correctly, just to make sure everything works before continuing. The rest is the same. We have changes in the loop too. And for the loop, we'll make sure if the ESP is not connected, it tries to reconnect. And here we get the actual time. We will use the current minute and current second below, and this is the timestamp to keep track of when the data was collected. These two will be displayed on the ESP screen. It shows if the buffer has anything, or how much data is buffered, and this is for pushing the data. So the condition I have here is each 5 minutes it will run this code here. For example, 17:00 it will run. If it's 17:05 it will run again. 17:10 it will run. So that's how it works. Here the payload will be prepared. Just structure the data, how it will be pushed. Here it will try to publish the data collected. So if the ESP is connected to the Wi-Fi and connected to the MQTT server, it will flush the buffer. Means if the buffer has anything, it will flush it first, push the data in the buffer, then publish what's collected at the moment. If it's not connected, it will push it to the buffer. That's it. And for those libraries, we will need to add in the platform IO these two lines. You'll find them in the repository too. And before pushing the code to the ESP, let's set up the MQTT server and the NTP. So what's MQTT, or Message Queue and Telemetry Transport? Oof! MQTT is a lightweight messaging protocol where devices publish data to topics, and other devices subscribe to those topics to receive the data. In our case, client 1, the publisher, is the ESP. It publishes the data to weather/data topic we specified in the code. Now let's set up the MQTT broker. I'll go with Mosquitto. Let's install it now. First sudo update. Then sudo apt install. This is the Mosquitto and Mosquitto clients. For testing, we will need this. And to make Mosquitto run whenever the machine is up, we will need to enable it in the system control. Next, this is the configuration I'm working on. You'll find it in the repository too. Most importantly, allow anonymous must be true for the ESP to connect without needing to authenticate. Next, let's restart the service. Oopsie. Let's restart it. And that's it, Mosquitto is set up. Let's test it out. So for the MQTT server, we have a publisher and a subscriber. So let's subscribe for the MQTT server here, and let's publish something from another terminal. For example, let's publish hello world. And if we go to the first terminal, we will see hello world published. So Mosquitto is well set up. And let's go to the NTP server. But before that, why do we need the NTP server? The ESP has no real-time clock. It can't know what time it is at the moment. And we need the NTP server so the ESP can get the correct current time. I'm using the local NTP server, so I don't have an internet dependency. So let's start by, of course, update. And this is the NTP server I will use, Crony. Also, let's enable it so it runs as soon as I run the machine. And you will need also to edit the configuration file of the Crony. This is the path, and I'll provide the configuration I'm using here. This takes the time from the local machine for the NTP server, and you need to make sure your LAN IP is as follows. It's 192.168.0, not 0.1. Sometimes it may be 1 here. How will you know? Just hostname -i. This is my machine's IP, so it's 0 right here. If you have 1, you need to make it 1 here. And that's it. That's for the configuration of Crony. And you need to restart the service. That's it. So just to test it out, to see if it's working. It is actually working. I'm at Saturday, November. This is the date I'm recording the video. Let's see when I will upload it. Hopefully not too late. Now let's go to uploading the code to the ESP. So this is the circuits we made the last time. So let's push the new code to it. Here is it working, connecting to Wi-Fi. Okay, everything is working normal. As you can see, we have only this buffer count that's different from the last time. So this is it. That's the data being published to the topic we specified in the ESP. So I hope everything was clear, and if you have any questions, don't hesitate to ask me in the comments below. And thank you for watching.